Hello, this is problems number 8 through 11. If you're looking for anything 1 through 7, that's a different video. We'll get right into it. The probability of spinning a 1 on the first spinner and 1 on the second. There's 1 out of 4 on the first, 1 out of 3. That word and means to multiply. I could do a tree diagram, but it's going to be a lot easier just to use the multiplication. 112. Jan has 3 scarves, 4 shirts, 2 pants. How many different outfits? If you have to have one of each, that is called the fundamental counting principle. 3 times 4 times 2. If I'm just looking for number outcomes, I can multiply them. 12 times 2 is 24 different outcomes. All right, here we go. There is our list of all our probabilities. So let's answer these questions. Exactly 2. Exactly 2 is right there. So the probability is 0.28. Okay. More than 2. More than 2 is 3 and 4. So I'm going to add those together. 0.39 plus 0.12 is equal to 0.51 or 51%. At least. So I'm taking more than 2 and adding in 2 to it. So 0.28 is 2. More than 2 is 51. So at least is 2 or more. So if I put that together, that is a 79% chance, or 0.79. Okay? Find the probability it does not eat exactly 2. This is, again, called the complement. So if I have 1 or 100%, I take away 28%, that is exactly 2. Everything else is not exactly 2. So 1 minus 0.28 is 0.72, so there's a 72% chance he does not eat exactly 2. Okay, here we go. Another tree diagram. Sample says flipping a coin and rolling a number cube. I'm going to do it in the order they give me. The order doesn't matter. You could do the number cube first. I am going to do heads or tails first. And, oh, that was ugly. Then I am going to do this, where I'm just going to copy that. Duplicate. Whoop. All right, there is my tree diagram. Only put on there the results of what you could get. You should not have coin and number cube. How many outcomes are there? Well, I could count all the way to the right, or I could do 2 from the coin, 6 from the number cube to get a total of 12. The probability of each outcome is 1/12. Is each outcome yes? Okay. Why is that? Because the heads and tails was equally likely, as were 1, 2, 3, 4, 5, and 6 when we roll a number cube. So nothing was weighted more than the other. Okay. What is probability of getting a heads and an odd number? Well, if I look back here, there's a heads and an odd, there's a heads and an odd, and there's a heads and an odd. So that is 3 out of the 12. So the probability of getting heads and odd is 3 out of 12, which reduces down to 1/4. Tails in an even, I'm going to highlight in a totally different color. Tails and even, tails and even, tails and even. That is, again, 3 out of 12. So the probability of tails and even is equal to 3 out of 12, or 1/4. Okay? Double check your work. Email me with questions.